Welcome. In this session, we're going to do two examples of calculating limits by using table of values. This time, we're going to do examples with exponential functions. This poses some challenges, which I will come back to when we talk about finding limits algebraically by doing algebraic calculations. But for now, let's just do the examples the way we did that in the introduction. The first example is the limit as h goes to 0 of 1 plus h to the power 1 over h. So we're going to take values of h going towards 0. So we'll start with 1 and then take 0.1, 0.01, 0.001, etc. And also their negatives. So you plug in the value. If I plug in 1 for h, I get 1 plus 1 to the power 1 over n. That's 2 power 1 or 2. If I plug in negative 1, I end up with 1 plus negative 1, that's 0 to the power negative 1, which is not defined. But for other numbers in this list, that expression will be defined. So if you plug in 0.1, you get 1 plus 0.1 or 1.1 to the power 1 over 0.1 or 10. So it's 1.1 to the power 10. If it's negative 0.1, you get 0.9 to the power negative 10. You calculate these values. So now it's just a matter of calculation. I'll just show you what the numbers are. Now if you look at the numbers, you see that these numbers are increasing. These are decreasing. These are always above these numbers. And they look like these are both coming towards some common point in the middle. We don't know what it is. These are not approaching some nice round number, so we just have to make a guess. But we can say since these two numbers agree with each other to two decimal places, the number in the middle should be what the common value is to two decimal places. It's 2.72. Our next example is 2 power h minus 1 over h as h goes to 0. So again, I'm just going to plug in values of h that are close to 0. We'll pick the same ones as before, 1, 0.1, 0.01, 0.001, they're negatives. Now just a matter of calculation again, so I'll just show you the results. Now if you look at this, again it looks these are increasing, these are decreasing. It looks like these numbers are both approaching something in the middle, which to three decimal places should be same as these two, which is 0.693. Of course, this assumes that these numbers behave the way they are doing so far, that nothing surprising happens in the middle. It's a problem that we will face whenever we try to estimate limits by calculating and tabulating values. We can also do this more mathematically, but that involves more complicated mathematics than we will do in this course. But we can show by using other techniques that the first limit is in fact e and the second limit is natural logarithm of 2. The first limit is something you might have seen before. It's what you come across when you do continuous compounding. So as you make x larger and larger, 1 plus 1 over x to the power x gets closer to e, as you saw in 1130. This was the basis of the continuous compounding formula. And the limit we did is same as this, except we are using h in place of 1 over x. So the moral of the story is that trying to estimate limits by tabulating doesn't always tell us the exact limit, but if we're willing to accept approximate answers, that's fine. I will stop this session here. We'll look at other things about limits the next time. Bye for now.